The looming disaster scientists aren't talking about involves Earth's dying oceans and a chemical collapse that few people understand. While we focus on rising tides, a much more immediate threat is quietly choking the life out of sea. For millions of years, the cold currents have delivered oxygen to the abyss, but that ancient cycle is breaking. Warmer waters at the surface act like a lid, preventing the deep from receiving the vital gases it needs. This stratification is creating massive pockets of toxic water, where almost nothing can survive for more than a day. Could this silent suffocation be the tipping point that triggers a mass extinction event within our own human lifetime? The ocean has lost roughly 2% of its total oxygen since 1960, and that number is accelerating faster than most climate models ever predicted. Dead zones, regions where dissolved oxygen drops so low that fish suffocate within hours, have more than quadrupled in the last half-century. What makes this crisis so dangerous is that it's invisible from the surface, unfolding in darkness, beyond the reach of any headline. The systems that have sustained complex life on this planet for hundreds of millions of years are quietly, irreversibly beginning to fail. The ocean breathes, and it has done so for hundreds of millions of years without interruption. Wind drags across the surface and forces oxygen down into the water column below. That churning at the surface is not chaos. It's the first step in a system that sustains all marine life. Cold water, dense and heavy, sinks from the poles and carries dissolved oxygen into the deep ocean. This slow conveyor belt of water, driven by temperature and salinity, is called thermohaline circulation, and it reaches every basin on Earth. Meanwhile, phytoplankton, microscopic organisms near the surface, photosynthesize sunlight and produce roughly half of all the oxygen on this planet. These three mechanisms work in concert: surface mixing, deep circulation, and biological production, each one reinforcing the others. A healthy ocean is not simply full of water. It's full of moving, breathing, living chemistry. Every creature below the surface depends on that system functioning exactly as it always has. Warm water and cold water don't mix the way most people assume they do, and that gap is lethal. Cold water is denser, so it sinks, pulling oxygen-rich surface water downward and driving the ocean's great circulation engine. But as surface temperatures rise, that density difference shrinks and the engine begins to stall. The warm layer on top becomes lighter and lighter, sitting on the cold water below like a lid sealed over a jar. Oxygen produced at the sunlit surface can no longer reach the depths where creatures depend on it to survive. Scientists call this stratification, and it's been accelerating across every major ocean basin since the 1960s. The deeper layers aren't just getting less oxygen, they're getting cut off entirely from the source. A warmer ocean isn't just uncomfortable for marine life, it's structurally incapable of delivering what life below the surface needs. And where oxygen stops reaching, something far more visible begins to take its place. The Gulf of Mexico holds a dead zone the size of New Jersey, and it returns every single summer. It's not a prediction or a warning. It's a fixture, mapped and measured for decades by NOAA researchers who watch it grow. The Chesapeake Bay, the Baltic Sea, the Black Sea. Each one carries its own suffocating pocket of water where oxygen has simply collapsed. Scientists now count over 400 of these hypoxic regions scattered across the world's coastlines and open ocean. That number has quadrupled since 1950, tracking almost perfectly with rising global temperatures and industrial runoff. In the Bay of Bengal, fishing communities pull up nets full of nothing because the fish have fled the dead water below. The Arabian Sea hosts one of the largest oxygen minimum zones on Earth, expanding quietly beneath the surface where no camera follows. These aren't isolated accidents, they're a pattern, and the pattern has a direction. Every decade, the dead zones grow wider, sink deeper, and stay longer than the decade before. The ocean isn't warning us from the future. It's already showing us what losing oxygen looks like. The first creatures to die aren't the ones you'd expect. They're the ones too slow to run. Bottom dwellers like crabs, clams, and sea cucumbers suffocate in place when oxygen drops below 2 milligrams per litre. That threshold sounds technical, until you realize it marks the line between a living sea floor and a graveyard. Fish flee toward shallower, cooler water, but the oxygen there is already thinning from the surface down. They're not escaping the dead zone, they're chasing a shrinking refuge that moves faster than they do. The food web doesn't collapse all at once, it unravels from the bottom, one broken link at a time. Zooplankton populations crash first, and the fish that feed on them follow within seasons, not centuries. Apex predators like tuna and sharks arrive last to the crisis, but they arrive to nothing. Their prey is already gone. What's left is a vast, warm, oxygen-starved water column where almost nothing survives. And the fishing nets humanity has cast across these waters for generations are starting to come up empty. 3 billion people depend on the ocean for the protein that keeps them alive every single day. That number isn't a statistic to file away. It's the weight of what's already at risk right now. As oxygen levels drop in the ocean's mid-layers, fish don't simply relocate to safer water and carry on as before. They compress into narrower bands near the surface, crowding into shrinking zones where oxygen is still just barely enough to survive. Commercial fishing fleets follow those fish, and the catch per trip is already falling in oxygen-depleted regions across the Pacific and Indian Oceans. Smaller catches mean higher prices, and higher prices mean the world's poorest coastal communities lose access to food they've eaten for generations. The economic damage doesn't stop at the shoreline. It moves inland, through supply chains, through markets, through the cost of a meal on an ordinary table. What's disappearing from the deep isn't just marine life. It's the foundation of a food system billions of people have never thought to question. And the geological record suggests this isn't the first time the ocean has reached this edge. The ocean has suffocated before, and the fossil record tells us exactly how that ended. Around 252 million years ago, the Permian-Triassic extinction erased roughly 96% of all marine species from existence. Oxygen-depleted water spread across the seafloor in a slow, invisible wave of death that took millions of years to reverse. Scientists call these events ocean anoxic events. moments when dissolved oxygen collapses across vast stretches of the deep sea. The Cretaceous period saw multiple such events, each one leaving behind thick black layers of sediment, the chemical signature of a sea that stopped breathing. These weren't random catastrophes. They were triggered by warming oceans, disrupted circulation, and runaway carbon in the atmosphere. The conditions that caused them are not ancient mysteries. They are a checklist, and we are working through it right now. What took volcanic eruptions millions of years to achieve, we have begun compressing into decades. The ocean has a memory for collapse, and it's starting to remember. The models scientists run today don't offer comfort. They offer a range of outcomes, and every scenario demands a decision. If warming continues at its current pace, ocean oxygen could fall another 3 to 4% by 2100, enough to collapse entire regional fisheries. That number sounds technical until you map it against the billion people who depend on seafood as their primary protein source. Dead zones, which now number over 700 globally, would expand into waters that still feed the world. The tipping points are what keep marine scientists awake. Thresholds where gradual loss becomes sudden, irreversible restructuring of ocean chemistry. We don't know exactly where those thresholds sit, and that uncertainty is not reassuring, it's the warning. Reducing carbon emissions slows the warming that drives stratification and oxygen decline, and that connection is direct, not theoretical. Cutting agricultural runoff shrinks the dead zones that are already here, and that work can begin without waiting for a global agreement. The ocean hasn't crossed the point of no return, but the margin is narrowing. With every year we treat this as tomorrow's problem.